What if the Milky Way collapsed into a giant black hole? What if everything you know, every star, every planet, every cosmic landmark of our galaxy suddenly began collapsing toward a single point? What if the Milky Way, home to over 100 billion stars, including our sun, started folding into itself, shrinking, tightening, and turning into the largest black hole the universe has ever seen? No warning, no escape, just a slow, unstoppable gravitational fall toward oblivion. This is not science fiction. This is exactly what physics says would happen if the Milky Way collapsed into a giant black hole, and what it would mean for Earth, humanity, and the fate of the universe. Let's begin. The first rumble, when the galaxy starts to fall. The Milky Way is not a peaceful place. It is already drifting toward catastrophe, gravitational battles, star collisions, and a future collision with the Andromeda Galaxy. But in this scenario, something far more dramatic happens. A catastrophic chain reaction is triggered at the galactic core. The supermassive black hole at the center of the Milky Way, Sagittarius A, suddenly becomes unstable. Its gravitational pull increases exponentially, like a cosmic vacuum cleaner turned to maximum power. At first, nothing seems unusual. Earth rotates, the sun shines, life goes on. But deep in space, stars thousands of light years away begin spiraling inward. Imagine watching a whirlpool swallow an entire ocean, except the ocean is our galaxy. Astronomers on Earth would be the first to notice the abnormal motion, but their warnings would come too late, because what happens next cannot be stopped. The Oreo effect. Galaxy spaghettifies itself. A collapsing galaxy doesn't fold neatly like a piece of paper. It stretches. The Milky Way begins to warp, twist, and deform. The elegant spiral shape that humans admire in pictures becomes distorted beyond recognition. Stars at the outer edge feel the pull first. They begin drifting inward, accelerating with unimaginable speed. The spiral arms stretch like melted rubber bands. Every planet orbiting these stars is thrown into chaos. Solar systems tear apart as their suns spiral toward the center. This is not a collapse. It is galactic spaghettification. The cosmic dance holding everything in place, gravity, inertia, orbital balance, is shattered. Over millions of years, the entire galaxy compresses into a tighter, hotter, more violent version of itself. But what does this mean for Earth? Let's zoom in. The Earth feels the first pull. We live 26,000 light years from the center of the Milky Way. That distance normally protects us from the chaos near the core. Not anymore. At first, extremely subtle changes happen. The night sky shifts. Constellations warp as stars start drifting toward the center. The Milky Way band across the sky becomes brighter, then thinner, then distorted. Animals sensitive to magnetic fields begin acting strange. Birds lose their sense of direction. Whales migrate in the wrong direction. Insects swarm without pattern. Humanity notices something even stranger. The sun begins to wobble. Why? Because gravitational forces around the solar system are changing. We begin drifting, ever so slightly, toward the galactic core. It's slow, centimeters per year, then meters, then kilometers. It feels harmless, until it isn't. The sky becomes unrecognizable. As millions of stars fall inward, the night sky becomes a fireworks show nobody asked for. Entire suns collide. Massive shockwaves ripple through space. New black holes form like sparks from cosmic explosions. To the naked eye, Earth's sky becomes brighter than any night sky ever recorded, filled with streaks of dying stars, scattered with supernovae glowing like miniature suns. Astronomers would be overwhelmed. There would be more supernova explosions in 1 century than in all recorded human history. Imagine standing outside at night and watching a star explode every few weeks. Beautiful, terrifying. But beauty is not the danger. The danger is what these explosions send our way. Gamma radiation, X-ray bursts, high-energy particles capable of stripping Earth's atmosphere. Earth suddenly becomes vulnerable, very vulnerable. Earth's orbit starts to break. As the galaxy collapses, gravitational chaos grows exponentially. Our solar system becomes unstable. Planetary orbits shift. Jupiter moves slightly inward. Saturn's rings begin tilting unnaturally. Comets are ripped from the Oort cloud like crumbs pulled into a vacuum cleaner. Then comes the worst shock. Earth's orbit becomes elongated. Instead of our normal circular path, Earth starts following a stretched, unstable path around the sun. This means hotter summers, colder winters, longer seasons, more violent storms, global climate unpredictability, ice caps melt, then refreeze, crop cycles collapse. Human civilization starts to break down as nature becomes increasingly unrecognizable. And this is just the beginning. The final millennium. Earth is dragged into the chaos. The solar system is now drifting like a leaf caught in a whirlpool. Each year, the inward pull becomes slightly stronger, slightly closer, slightly faster. We begin falling toward the collapsing Milky Way core. Astronomers predict our eventual fate. Earth will not fall directly into Sagittarius A. Something else will likely destroy us first. As we drift into thicker star fields, the risk of collision skyrockets. A rogue star could pass too close. A gas giant from another solar system could drift into ours. An asteroid belt from a dying star could sweep across our path. Space becomes crowded, dangerous, chaotic. Imagine driving on a highway where every car is losing control. That's our galaxy right now. One close encounter, even a star passing within a light year, could destabilize Earth's orbit enough to doom us. But there's something even scarier, the supermassive jet, a beam of pure destruction. As the Milky Way collapses, Sagittarius A, the central black hole, stops being calm and quiet. It becomes violent. It begins feeding on hundreds of stars per year, and like all voracious black holes, it produces a relativistic jet, a concentrated beam of high-energy particles shot into space at nearly the speed of light. These jets are deadly. They can sterilize entire solar systems. They can evaporate atmospheres. They can destroy planets from across the galaxy. If one of these beams sweeps across our part of the galaxy, Earth is gone. Not burned, not shattered, just gone. A single blast would remove the ozone layer, boil the oceans, and strip Earth down to a barren rock in minutes. Whether we survive depends purely on direction, luck, nothing else. Approaching the point of no return. If somehow we survive the jets, radiation, supernova storms, drifting stars, and orbital chaos, we still face the ultimate doom. The solar system reaches the innermost region where gravity overtakes stability. This is the point of no return. We begin falling inward rapidly. The sun brightens as gravitational forces compress it. Solar flares become violent. Radiation levels skyrocket. Earth's magnetic field weakens and collapses. Solar radiation floods the planet. The atmosphere begins eroding. Oceans start boiling at the surface. Skies turn orange, then red, then black. Human survival becomes impossible. Civilizations would collapse. Only underground bunkers or space colonies could prolong life, but only for a while, because what comes next is inescapable. Earth is dismantled. As we fall inward, gravity becomes horrific. Planets are no longer stable objects. They stretch, deform, and fragment. Earth begins cracking, first the crust, then the mantle, then the core. Volcanoes erupt worldwide. Earthquakes tear continents apart. The planet becomes a glowing, molten sphere. The moon is ripped apart. Its fragments form a temporary ring around Earth before getting sucked inward. Eventually, Earth begins spaghettifying, literally stretching into a long ribbon of atoms. This is the end of our world. The final pieces spiral into the growing black hole at the center. Humanity's home is erased from existence. After the collapse, what remains of the galaxy? When the collapse is complete, the Milky Way is gone. In its place, a single monstrous black hole, billions of times the mass of our sun. Dark, silent, featureless. All stars, all planets, all nebulae, all life, all history. Gone. But the universe continues. Other galaxies drift through space unaffected. Cosmic expansion keeps going. New stars are born in distant galaxies. Life continues elsewhere. The universe does not mourn. This is the cold beauty and brutality of cosmic physics. The lesson of the collapsing galaxy. What does this collapsing galaxy scenario really teach us? That we're living on a fragile blue dot, circling an ordinary star, in a universe that doesn't care whether we exist or not. Our time here is temporary, rare, and unbelievably precious. The universe isn't cruel, just indifferent. And that's exactly why protecting the home we have matters. One day, everything will fade, but until then, we keep exploring, we keep questioning, we keep imagining. If you want more videos like this, like the video, comment your thoughts, and subscribe for the next journey into the unknown.